Welcome to today's episode of Tech Talk, where we dive into the fascinating world of software performance and explore innovative tools that are reshaping how we work with files in Java. Today, we're going to discuss JUring, a high-performance Java library that connects to Linux's JUring asynchronous I/O interface using Java's foreign function and memory API. Now, let's start with a bit of context. If you've ever worked with file input-output in Java, you might have encountered Java NIO's file channel. It's a reliable method, but what if I told you there's a way to speed up those file operations significantly? That's where JUring comes in, boasting impressive performance enhancements. In fact, JUring can achieve, get this, 33% better performance with local files and a whopping 78% improvement for remote files compared to traditional file channel operations. Isn't that incredible? To give you a clearer picture, let's break down some benchmarks. On a Linux machine with a powerful setup, running on an NVMe SSD, and even on remote directories, we see JUring outperforming the competition hands down. For local operations, JUring processed 127 transactions per millisecond, while the traditional file channel only managed around 847. That's a significant leap. Now let's talk about remote file performance. This is where things get really impressive. When using network-mounted storage, JUring clocked in at around 1.729 ops/ms, while the file channel lagged behind at just 1.078 ops/ms. So if you're working with remote files, JUring could save you a lot of time and hassle. But how does it work? JUring provides two distinct methods to interact with files, the direct and blocking APIs. The direct approach allows you to prepare entries and match them with results based on an ID, while the blocking API simplifies handling for virtual threads. This flexibility means that whether you're building high-performance applications or just tweaking your file operations, JUring has got your back. Speaking of which, let's dive deeper into how you actually use this library. For instance, suppose you want to read from a file using the blocking API. You'd first set up JUring with a defined queue depth. After preparing your read operation, you would submit it and process the results once it's complete. For those more adventurous, the non-blocking API allows for more sophisticated execution without getting stuck waiting for operations to finish. Now, a quick word of caution. JUring is not thread safe, so you'll want to keep one instance per thread to maintain its efficiency. This might seem like a limitation, but it's designed this way to optimize performance. And like any technology, JUring is continuously evolving. The current version has some limitations, such as higher memory usage and instance creation times. However, the developers are hard at work tackling these issues, looking to bolster memory efficiency, add more features, and enhance usability. So whether you're a developer working on performance-heavy applications or just curious about the latest in Java file I/O, JUring is definitely a tool worth exploring. As we wrap up, consider this. What if you could incorporate such a performance boost into your existing applications? How would that change the way you handle file operations? Thanks for joining us today. Be sure to check out JUring if you're in the Java ecosystem, and keep pushing the boundaries of what's possible with software. Until next time, happy coding.